Good afternoon, tenfold. Rafira Mabudilala speaking from Limpopo High School at KL Secondary School, and I'd like you to help me with this question here. Thank you.
This wildcard question involves both geometry and calculus, so you kind of have to intermingle your theoretical knowledge, and I love this question. So let's just hop right into it and take a look at it. It says, in the sketch, triangle ABC is an equilateral triangle, okay? That is very important because equilateral triangles have their own characteristics to them. It says with sides equal to y units. Now remember, equilateral triangles have all sides equal and all interior angles are 60 degrees. Remember, in an equilateral triangle, all of the interior angles are equal to each other. Angles of a triangle add to 180, so all three of them are 60 degrees. Lastly, it says DEFG is a rectangle with BE equal to FC, which is equal to 6 units. So BE down here is X units, and so is FC. It's 6 units. It's X units. I'm talking absolute nonsense today. Okay, so BE is equal to FC, which is equal to X units. And remember, a whole side of this equilateral triangle is Y units. Remember also, equilateral triangles, 60 degrees all round. Lastly, you also need to remember that because DEFG is a rectangle, it's also got its own properties. It's got two pairs of opposite sides equal to each other, and also all of its interior angles are 90 degrees. Okay, so great application of your geometric knowledge, first of all. So, firstly, we get asked to prove that the area of the rectangle is equal to the square root of 3 multiplied by xy minus 2 times the square root of 3 multiplied by x squared. Okay, so firstly, let's just try and find an expression for the area. You know that the area is equal to length times breadth in a triangle or a rectangle. So, in this case, I'm going to say that the length is EF and the breadth is FG. So we have EF multiplied by FG. Now, if we try and look for expressions for these two sides, we can see that EF forms a side of the triangle. So we have the whole side equal to Y. We have E there, F there, an X there, and an X there. So EF is equal to the whole side Y minus 2x. Okay. So EF is y minus 2x. And now we need to find an expression for FG. So the reason we get told that it's an equilateral triangle is because now we have this lovely little triangle down here, GFC. Remember, if this is 90 degrees here, it means that this is automatically 90 degrees. We've got 60 degrees there, X here, and we're trying to find FG. So we've got a lovely 90-degree triangle, which means another section, trigonometry, is brought into this question. So we've got the opposite side to our 60 degrees, the adjacent side, which means that we're using tan. Tan of 60 degrees is equal to the opposite, GF, over the adjacent of X, which means that GF is equal to X multiplied by tan of 60. And remember, your special angle is tan of 60 degrees is equal to the square root of 3. So we know that GF is the square root of 3 multiplied by X. So now we can fill that in here. Root 3 multiplied by X. So now if we multiply these two brackets out, we're going to get the square root of 3x multiplied by y minus 2 multiplied by the square root of 3 just gives us 2 root 3, and x multiplied by x is x squared. And that's exactly what we had to prove over here. Okay, easy peasy. Secondly, it says determine in terms of y, very important, in terms of y, the maximum area of the rectangle. Okay, so firstly, remember, area of the rectangle we found was root 3xy minus 2 root 3x squared. Let me just double check that. Root 3xy, yeah, 2 root 3x squared. Okay, so now they're saying in terms of y. So remember, if you're trying to find the maximum, you need to first differentiate and then make the first derivative equal to 0. Because remember, when we get a graph that looks like this, as this would, because it is a square function, or like this, when we're trying to find a maximum, we're trying to find where the gradient is equal to 0. And the first derivative gives us the gradient, so we make it equal to 0. So the first derivative of this, with respect to x, we're going to say dy by dx. Remember, you multiply by the exponent of x, so you get the square root of 3. Subtract 1 from the exponent of x, which means x will be raised to the power of 0, which is 1, and we still have y. Y is a constant in this instance. Okay. If we differentiate the second term, 2 multiplied by 2, which is the exponent, is 4. Square root of 3 multiplied by x. Okay. So now we make this first derivative equal to 0. So we get the square root of 3 multiplied by y minus 4 root 3 multiplied by x is equal to 0. So now remember, we're trying to solve in terms of y. So I want to try and get my expression as an expression of x so that I can substitute it into this original expression, because if I substitute x into this expression, I'm going to get in terms of y. That might sound complicated, but let me go through it. So square root of 3 multiplied by y is therefore equal to, this negative becomes a positive on the other side. We get 4 multiplied by the square root of 3x. Okay, so now I want to try and isolate x. So we divide by 4 root 3, 3 root y, or root 3y over 4 root 3 is equal to x. And now we know that the root 3's are going to divide into each other. So we get that x is equal to a quarter y. And the reason I put it in terms of x is because now we can take this expression and substitute it all the way up here back into the original area, which is what we're trying to find, the maximum area in terms of y. So remember, area was root 3xy minus 2 root 3x squared. So now every time we see an x, we can substitute this expression for x into it, and we'll be left with only y expressions. So the maximum area is equal to the square root of 3 multiplied by x, which we've just found is a quarter y, multiplied by y, there's still another y there, minus 2 root 3 multiplied by x, which is a quarter y, all squared because we have x squared. So now if we multiply this out, we're going to get root 3 over 4 multiplied by y squared minus 2 root 3 over 16. Remember, 4 squared is 16, y squared. Okay, and now if we want to try and add or subtract these two from each other, remember, common denominator. So we multiply this entire fraction by 4. We get 4 root 3 over 16 y squared minus 2 root 3 over 16 y squared. And now because they are like terms with common denominators, we can simply subtract. So 4 root 3 minus 2 root 3 is 2 root 3 all over 16 y squared. And we can easily simplify that to just root 3 over 8 because 2 goes into itself once and into 16 8 times. Root 3 over 8 y squared, and that is the maximum area in terms of just y. Okay, so I really love this question because it really highlights what you need to try and solve for. If it says in terms of y, you want to find a variable that you can express in terms of y that you substitute into your original function equation. Hopefully that makes sense. But this question is so great. Trigonometry, geometry, and calculus all in one question. Fantastic analysis of your understanding of mathematics.